Welcome and hello everybody to our course on JavaScript for beginners. In this course, we will do many things. You can see them here on the screen. Learning objective for this lecture. We will introduce you about programming and the interface of AppLab. The definition of programming. Programming is a set of instructions directing a computer to perform a task. The definition of a programming language. It is a special language used to write a program. What is an algorithm of a program? An algorithm is a set of well-defined steps to perform a task. These steps are performed sequentially. The upcoming video will explain it in more details.
What's an algorithm? In computer science, an algorithm is a set of instructions for solving some problem, step by step. Typically, algorithms are executed by computers, but we humans have algorithms as well. For instance, how would you go about counting the number of people in a room? Well, if you're like me, you'd probably point at each person, one at a time, and count up from 0. 1, 2, 3, 4, and so forth. Well, that's an algorithm. In fact, let's try to express it a bit more formally in pseudocode. English-like syntax that resembles a programming language. Let n equal 0. For each person in room, set n equal to n plus 1. How to interpret this pseudocode? Well, line 1 declares, so to speak, a variable called n and initializes its value to 0. This just means that at the beginning of our algorithm, the thing with which we're counting has a value of 0. After all, before we start counting, we haven't counted anything yet. Calling this variable n is just a convention. I could have called it most anything. Now, line 2 demarks the start of a loop, a sequence of steps that will repeat some number of times. So in our example, the step we're taking is counting people in the room. Beneath line 2 is line 3, which describes exactly how we'll go about counting. The indentation implies that it's line 3 that will repeat. So what the pseudocode is saying is that after starting at 0, for each person in the room, we'll increase n by 1. Now, is this algorithm correct? Well, let's bang on it a bit. Does it work if there are 2 people in the room? Let's see. In line 1, we initialize n to 0. For each of these 2 people, we then increment n by 1. So on the first trip through the loop, we update n from 0 to 1. On the second trip through that same loop, we update n from 1 to 2. And so, by this algorithm's end, n is 2, which indeed matches the number of people in the room. So far, so good. How about a corner case, though? Suppose that there are 0 people in the room, besides me, who's doing the counting. In line 1, we again initialize n to 0. This time, though, line 3 doesn't execute at all, since there isn't a person in the room, and so n remains 0, which indeed matches the number of people in the room. Pretty simple, right? But counting people one at a time is pretty inefficient too, no? Surely we can do better. Why not count 2 people at a time? Instead of counting 1, 2, 3, 4, 5, 6, 7, 8, and so forth, why not count 2, 4, 6, 8, and so on? It even sounds faster, and it surely is. Let's express this optimization in pseudocode. Let n equal 0. For each pair of people in room, set n equal to n plus 2. Pretty simple change, right? Rather than count people one at a time, we instead count them 2 at a time. This algorithm's just twice as fast as the last. But is it correct? Let's see. Does it work if there are 2 people in the room? In line 1, we initialize n to 0. For that one pair of people, we then increment n by 2. And so by this algorithm's end, n is 2, which indeed matches the number of people in the room. Suppose next that there are 0 people in the room. In line 1, we initialize n to 0. As before, line 3 doesn't execute at all, since there aren't any pairs of people in the room. And so n remains 0, which indeed matches the number of people in the room. But what if there are 3 people in the room? How does this algorithm fare? Let's see. In line 1, we initialize n to 0. For a pair of those people, we then increment n by 2, but then what? There isn't another full pair of people in the room, so line 2 no longer applies. And so by this algorithm's end, n is still 2, which isn't correct. Indeed, this algorithm is said to be buggy because it has a mistake. Let's redress with some new pseudocode. Let n equal 0. For each pair of people in room, set n equal to n plus 2. If one person remains unpaired, set n equal to n plus 1. To solve this particular problem, we've introduced in line 4 a condition. otherwise known as a branch, that only executes if there's one person we could not pair with another. And so now, whether there's 1 or 3 or any odd number of people in the room, this algorithm will now count them. Can we do even better? Well, we could count in 3s or 4s or even 5s and 10s, but beyond that it's going to get a little bit difficult to point. At the end of the day, whether executed by computers or humans, algorithms are just a set of instructions with which to solve problems. These were just 3. What problem would you solve with an algorithm?
We have now seen algorithms in code, and now we're gonna get into App Lab, and we will explain in details how to access it and how to use.
Me. There's probably been a time in your life when you thought, there should totally be an app for that. Making your own app has never been easier than it is with App Lab. It's a powerful tool for beginning computer science students to quickly build shareable apps that are relevant to their lives.
Here are 5 reasons that App Lab could be a great tool for your classroom.
1. Rapid prototyping. Students can go from an initial concept to a working prototype super quickly in App Lab. With just a few actions, students can see their idea come to life and exhibit interactivity.
2. Blocks to text. Coding with blocks introduces students to programming without needing to know much JavaScript syntax.
You can code in blocks, you can code in text, and you can actually drag blocks into text.
This makes programming approachable for new students and dynamic for more experienced students.
3. Building interactivity. You don't need to know any HTML or CSS to build these apps. In design mode, you can just drag buttons on, drag drop-downs on, any kind of UI element that you want to add. You can add that and then power it with the code.
4. Lightweight database capability.
Any kind of useful productivity or fun app, it's almost certainly is using a database in the back end, and that's normally a super inaccessible thing for new programmers to get going, and with the data blocks that we have built into App Lab, that's really easy.
You can build games that have a leaderboard across all your users, a quiz or survey that stores user responses so you can analyze them later, ratings and comments on an app that lets you rate movies or food or places to study. Programming with a database unlocks a whole new class of apps previously inaccessible to new programmers.
And finally, 5. Shareability.
Every app automatically has a unique URL so that once students have a working app, they can instantly share it with their friends and family on any device.
You can put in your phone number or put in a friend or family member's phone number and it'll text the link to them, and when they click it, they open it up and they're using your app on their phone.
It was kind of like the game Connected, where it was kind of like a puzzle and you have to fill in the grid with the colors. We all worked in groups and we were like, okay, so what do we want to do? What do the customers want to see?
The name of the game is called The Boat. It's very simple.
We built App Lab for our particular CS Principles course, but what's amazing about it is that it can be integrated really into any intro to programming class that any teacher is interested in using, and we're excited to share.
This was a quick introduction to App Lab. Now I will teach you how to access the lab. First, you type in code.org. Then you should sign in or create an account. Mine is already ready here. Once you sign in, you go down and you will find App Lab right over here. You click on it. And here you go, App Lab with its interface. First thing is Design App. From here you could choose a set of different designs. You could even add buttons, use labels, ratios, anything you want to add to your design can be found in here. And here is where you put your code. You can add blocks and change it into text if you want to. And you can even take blocks and put it into text. Here you can find your UI controls, adding data, statements, if else, and controlled variables. Here's variables, the turtle, math, and creating and using your function. This marks the end of this lecture, and we will see you again in the next lecture with more about coding in JavaScript using AppLab. Thank you very much for listening, and hope to see you next time.